In this video, I introduce the MLAgentBench, a benchmark for evaluating large language model agents. MLAgentBench consists of 13 executable tasks to automatically evaluate large language model agents. Each task is described by a task description, a set of starter files, and an evaluator. To evaluate agents on MLAgentBench, at each step, the prompt of a large language model is automatically constructed to summarize all known information about the task and prior actions, which produces a stepwise reflection, a high-level plan, and a factor checking section, a reasoning step before action, and the next action to take. The task includes a task description, starter files, evaluator. Given a task description, an agent can read, write files, and execute Python code. The agent is evaluated based on the results in the output file summation CSV. The observation on benchmark is formulated as a Markov decision process. This rational RT, this action, this state, and then we get this observation, and then go to next step. And finally, we collect all interaction trees to form a prompt PT to large language model. The task description describes the desired goal. The starter files include training, testing data, detailed data descriptions, metric descriptions, and the starter code in PyTorch, TensorFlow, JAX, and Keras. The evaluator assigns a raw score to a final summation. For example, gives the tester accuracy of predictions in the file summation .csv as a final summation. The agent operates over a sequence of time steps from 1 to capital T. At each time step, the agent uses the current memory MT-1 and workspace ST-1 to produce rational RT and action AT from this formulation. The environment executes action AT on workspace ST-1 to update workspace ST and then returns observation OT from here. The agent updates his memory MT-1 based on the action AT, rational RT, and observation OT from here. The procedure above is repeated until the agent decides to submit the final answer. After the agent submits the result, all actions A, responses R, observations O, and snapshots of the workspace S are recorded as interaction trees. The agent is evaluated from competence in accomplish the objectives and efficiency in terms of total amount of wall clock time spent and the total number of input-output tokens consumed by the agent, as shown here. As an example, a large language model is prompted to provide next step action AT and his arguments in a JSON format. The prompt PT starts with a description of all the actions available. The task descriptions are templated to instruct the large language model to produce text in passable format. And the last three steps taken including RT minus 3 to OT minus 1. The rationale RT and the action AT at each time step T are produced by this formulation. At each time step, the agent constructs a BT and queries the large language model to get RT and AT from a large language model, where AT is parsed from part of the large language model response RT. The example details of the large language model-based agent are demonstrated on the next page. This is a prompt to large language model. This is the agent response, and this is the observation. For more details, please check with these references. Thank you.